Bitwise operators. Okay, let me tell what is the need of these bitwise operators. Divya?
Yes, to do bit level changes.
To do bit level changes. Okay. And simply you can say like bit level manipulation. Bit level calculation or bit level operations. Operations done by these operators. Okay. Then after, what are the operators we have in bitwise operators?
And or XOR.
And or XOR.
Right shift, left shift.
Right shift, left shift.
Complement.
Complement.
Not.
Not is related to comes under bitwise.
Logical.
Means it is not a bitwise operator. Means if you are saying bitwise operator means it should be work on bit level. Okay, that's why it is not comes under bit level. Okay. Shall we discuss on that what Adarsh asked the same doubt or any better question? Do you have people any doubt in that bitwise operators? Any requirement?
Sir, can you tell me bit level hiding, like hiding concept where it is used and what is hiding? Bit level.
Come again, Vinay. I'm not getting your question.
Bit level hiding, sir. Hiding is used in what areas we will use? In which case we will use hiding? Means we won't change that particular bit level, like bit position from one position to another position. We won't change it.
Okay.
We will change the rest of that. Like that process in which areas, in which circumstances we will use.
Bit hiding means. Sorry, I didn't get. Present, I'm not getting the requirement. What exactly is? Anyone got the Vinay's requirement? Can you please elaborate it with what exactly the requirement is? If you're joining with a laptop, you can share your screen and show me the requirement. Exactly it is. We will discuss on that.
So I will frame question and ask. I will ask. You can continue that. I will ask.
Okay. Yeah. In Bitwise, na? Divya, you got that what others shared na, in that group? You got that question?
Yes, sir.
Answer also you got?
I didn't get that question.
Okay. Vinay, you are in that group. I think you are also in that group. But at that time, you are in or not, I don't know.
I think that time he is not there.
Sir, I am not.
Okay, at that time you are not in that group. That's why I didn't get
We'll
that
share the question to him, okay? Yeah.
The question is like what other shared. No? For suppose if you take one byte level. For suppose if this is the number, the requirement is you want to delete from the bit position. Bit position, you have to take the first any program. For suppose if you are having any requirement from the interviewer, first you have to get the clarity of the program. First you have to ask clearly what exactly he wants to. That's why others shared the question in that user will give the input. that is number. After that, he want to take position, from which position he want to start. Position also you want to take position. Then after, number of bits, which how many bits you want to delete from that position. Okay, first suppose this is the position from 0 through 7-bit positions we have. The number is same the number. Then the position, first suppose this use the selected number position as suppose 1. Then bits he want to delete, for suppose 3. That means from here to, from 1 position to 3 bits, means these 3 bits he want to delete. Okay, these 3 bits he want to delete. After this, if you after implement the program, the output should be he want to delete means 3 spaces created from the left side. Then 0 1 0 1 1. This is the output we have to get. Vinay, you got the requirement? Now what exactly you want?
Yes, sir, understood.
Yeah. Not 1 0 1 and 1. Yeah, this is the requirement. For this, Divya, may I know what approach you follow to get this requirement?
Read the bit.
Read bits by saying
And
this.
shifting. We should secure before positions. I mean, like 0th bit, we have to read and we have to store and shift 3 times so that this will get deleted.
Okay, wait. First, what you said? First, you have to store.
Yes.
Store unmodified data.
Yes.
Okay. For this, what is your approach? How you can store this data?
The bit position which the user has given is 1, no sir. So
Yes.
minus from that -1, all the bits we have to store.
Okay, how you can store? For suppose number position is for suppose 4th position. Then how you can store? Means 0, 1, 2, 3, 4.
Yes.
These data you have to store.
Right shift 4 times and store it in a variable. Right shift. 0x and with 4 ones.
And with 4 ones.
And store it in a variable.
And with 4 months means what? 1,
Then
2.
data we will get.
Okay, got the point. I said 4 ones. 4 1 means what? Up to now, 4th bit position means from position 4, no?
Yes.
From the position 4th, 0, 1, 2, 3, 4. From this position, he want to delete these 3 bits. Means, for suppose, this is a user choice, no? The number position may change. At the time, how you get? With every time we don't do every time with 4 ones, not AND operation with every time 4 ones, no?
Yes, sir.
Then
No. I'm not getting the Raj.
To get this, first we have to store the data. That's what we have to do. Simply, for suppose, take mask value as 1. Okay. For that one, you have to shift which position he will give as a requirement. That one you have to shift whatever the position he chosen. Then after, up to now you move to the position only, but we have to get not exactly that position. From before that position we have to store the data. For that we have to do -1. With this you can store, for suppose he choose this 4th position. First we have to shift our 1 to the 4th bit. Means up to your 1 came here. Then after, if you do -1 means the value become, you got all the upper bits. Got the point? Then you can do AND operation with the number. Whatever the number is given, with that you can do AND operation. With this you can store the unmodified number. Before that bit position, whatever you have, that value will be stored in that one variable. Then after you have to do shifting operation. Divya, got the point or any?
Now we have taken only one no sir. So if the bit position is 4, 4 minus 1 is 3. In the third position, my 1 will go and do AND with number. Then what about the 0th, 1 and second position bits?
Yeah, as you said means what? Up to now, 1 positions to 4. Okay. As I'm writing here, 1 left shift 4 times. Means what is the value of now? What is this resultant value?
2.
Means from 1 here, 1, 2, 3, 4. Means 1, 0, 0, 0. This is the value,
Yes.
Then after I am doing -1. What is this resultant value?
Okay. All ones.
8.
Okay.
Then after what I am doing? -1. What is its binary form? 7, we got 7. 7 means what? Ones.
Yeah.
Okay. Means simply what we are doing, we know if it is 1 at bit position means it should be definitely it is even only. For suppose if you take not only 4, now you got Divya,
Yes.
3 bit we are storing. 7 means. For suppose if you take only second bit position, 1 left shift to 2 means this is 0, 1 and 2. Means 1, 0, 0. This value is 4. Then -1 if you do, you got 3. 3 means 1, 1. 1, 2, 4, 8 minus 7. Yeah. Now you can store 0, 1, 2 position. From this you want to shift. Means before these two numbers you are stored by doing AND operation with that number. Divya, you got the point? why we are doing like
Yes,
this.
sir.
Then after, as you said,
Yes, sir.
simply you can do left shift. Whatever the number you have, no? That number with, we have to shift, means whatever the position he selected plus number of positions, number of bits he want to delete, no? Number of bits. That many times if you do right shift operation. Then after, with this what happen, whatever the bits, no? Whatever the bits you have, that will be gone in that number. But again we have to do right shift number of positions, which position he would taken. No? With this what happened, for suppose he selected 4, no? That means 4 positions we created spaces. But suppose he taken 2 bits from second bit position, that means if you right shifted 2 positions, means in there 2 positions we created to place whatever the unmodified data is there. Na? To store that, we have to do right shift again. After doing this, simply you can do OR operation with this and this value. With this, you can get the requirement, what exactly he asking. Got the point, Divya? Any doubt?
Yes, sir.
Yeah. Vinay, did you frame that question?
Sir, I will, sir, I am now listening. I will frame it.
Okay. As you asked, no, means we don't want to modify the data. Hiding means you don't, for suppose if you're giving any register, in that register, those bits are don't modified by the programmer, anyone. That is a requirement you want to ask.
Yes, sir.
That
We do not touch that one. Remaining we can do it.
Those bits are reserved bits. Okay. But if that means in real time, what we are doing means, as you also know, I think. Let me take whiteboard. See, in real time, what we are doing, for suppose it is status register. For example, you assume as a status register. It is 8-bit register. From 0 to 7, we have the bits. In that, what mentioned in the spec means 0, 1, 2, 3, 4, 5, 6. For suppose he has a product manufacturer, he said like these 2 bits are reserved. Don't utilize these 2 bits. In this way, what we are doing, for suppose if you want to check, as of now, Vinay, don't feel like present I am not getting the exact requirement, as we are the real-time employees, but Divya and others, they are giving the exact requirement only, I can explain them. But as of now, I will tell the real-time usage how we are doing. See, for suppose this is the one register in real time we are using. For suppose in that project, means in that spec, whatever the data sheet he given, in that is mentioned that 1, 2, 3, 4th and 5th bits are reserved. Don't modify and don't use these 2 bits. At that time, what we are doing, we are not doing any bit level manipulation on these 2 bits. Okay, simply we are using these bits only. Whatever the bits he given, like these 2 bits having some meaning, like to check the status is high or low. That in that scenario, we are doing simply read operation. By reading these 2 bits, 6th and 7th bit, for suppose to select the to test the status, then he mentioned like 6 and 7 bit. These 2 bits are checking the status of the sensor. At that time, what we are doing, by checking these 2 bits only, whatever the possible ways we have 0, 0, 0, 1, 1, 0, and 1, 1. For these 4 values, he given some description. If it is 0, 0, something, it is ideal condition. For suppose its value is 1, it is medium level. Yeah, come again. Yeah. Like that, what we are doing, simply we are reading. For suppose it is readable, means he will mention like read or write, readable or writable. In the datasheet, they will mention which bit are readable, which bit are read and writable. If it is writable, means we can modify the content also by using this feature. If it is writable, simply if you want to check, if you modify from, for suppose it is peak level, if it is take the temperature, if it is high mode, then you want to make it as ideal mode, then simply you have to write there 0, 0. If it is writable register, these 2 bits are writable, then you can do operation, write operation on these 2 bits. Like that, we are utilizing this register by using this bit level manipulation. Divya and Nandini and Adarsh, you people got the requirement what we are doing by using this bit level manipulations in real time?
Yeah, not fully, but yes, sir, partially. But
Yeah. Anyway, present you are using this on projects also, na, in your training period.
yes.
There, is it started or still it's pending? I think for Nandini it started, na?
For me, mini project completed.
Mini project completed. For suppose if you take a UART, in UART, what are the registers you have?
U0 LCR and U0 LSR.
No, don't tell like that in real time. For suppose if you get the interview, na, in that.
Transmission buffer, U0 THR and U0 RBR.
IDR means what? THR means what?
Transmission holding register and.
You have to tell full name. For suppose if someone asks, na, in every year, for suppose if you take any product, the functionality may be same, but the naming is different from product to product. As I said, the status register or as you said, transmit holding register. Like that, in that what you are doing, what about why you are using THR register?
To transmit the data.
To transmit the data means how we utilize this register?
Means we'll store here and from here we will transmit.
Okay, how we check the data is transmitted or not?
Fifth and sixth bits are in the LSR register, line status register we'll use. If that
LSR, na, line status register. At that time, we are not using all the bits. Yes. Simply, as you said, fifth and sixth, na? Simply, you are checking sixth bit and fifth bit.
Yes.
In real time, also, we are using same thing.
Okay.
This is the only thing. As you said, na, fifth and sixth. Here, I am taking sixth and seventh bit only. Okay. Like that, one more suggestion, like you completed the mini project, na? Yes. Whatever the data sheet they given, LPC 2148 or LPC 2149, just go to the spec. There, just note down the registers. For suppose if you are using UART, RI2C and SPI, whatever the protocol or whatever the component you are utilizing there, in the datasheet they will mention clearly what is the register, how many bits it is, what are the bit meaning, and it is readable or writable. Did you ever observe that any register having that only readable manner?
No.
Status register, have you ever heard? Status register.
Yes. Yes, sir.
Only readable only. By seeing that status register, you can guess is that computer or not, transmission computer or not, like that way. Okay? Yes. Like that, you are to familiar with at least three protocols. Anyway, you are using this one, UART and SPI. If you are practicing in CAN also, it is also fine. Just do this practice. Take any protocol on that protocol. I think in UART yet hardly you have 9 register. I think so. In LPC 2148. 9 register, I think so. Status register and this transport hold register, status register. For baud rate also you have the registers to set the baud rate in UART.
Yes. Yes.
Like
Control
that,
register.
control register. Like that, you have to make a node. Take one register, draw the bit levels like this. In that, each bit for what purpose? They will mention clearly in that data sheet. These bits for what purpose? Is those bits are readable or writable? Like that, you can make a node. It will helpful to until in your lifetime. If you make one node, you can store in Git and in your GitHub account also.
Okay.
Try.
So, in ARM, there are a lot of registers and bit positions, no, sir. How can we remember every bit in this register? This bit will be doing this work like that.
For suppose if you take UART only, for example, you take how you remember this fifth, sixth, and bit for THR register. You are checking fifth and sixth. How you remember this one?
I mean, like recently wrote the exam.
Yeah, means you are worked on that. In real time also, we are not work on every bit level. We are not remember every bit. No need to remember all the things. As you asked, no, is it necessary to remember all the things? No need to remember all the things. For suppose if you take a UART, with UART what you have done in your project, simply you are sending one character data. After that you are receiving one character data. To transmit and receiver, what are the registers involved in this task? In this task, what are the register you are utilizing? What are the bits you are using? That's enough to remember. If you got the requirement again, on that, no need to remember all this. Just open the spec, just go to the spec, read the registers, what it will mean. Is that register whatever the requirement you got, na? By that requirement, how you achieve the requirement by using that register. That's it. Means don't mug up all the things. Just go through the concept. For suppose if you take what it say, if you take I2C, in that I2C, you are using this serial clock and serial data.
Yes.
There are multiple clock polarity, clock phase also is there.
Yes, sir.
Not clock polarity, clock phase comes into the SPI. Here you got the clock statement.
Master and serial or serial.
Then you have to remember how the data transmitted, how you checking. For suppose if you are taking UART, in that UART you have the feature like error checking concept. For suppose if you take SPI, for example, I am taking two SPI devices. In these two SPI devices, for suppose I am sending one data. For suppose 101011, suppose this is the data, but I am not getting exactly the data. I am getting 101011. How can I check the data is received correct or not? How you check?
Parity bit.
Is there parity bit available in SPI?
Oh, SPI is not.
In UART you have, in
Yes.
ITC you have the acknowledgement concept, but in SPI we didn't have any this type of error checking method. Anyone? Others? Okay, Divya, this is the task for you. Okay, just
Okay.
go through the concept and discuss with your friends also. You got the requirement, na? What is the exact question is? For suppose in I2C, you are in I2C, we have the error checking methods. In CAN also we have the plenty of error checking methods. But in SPI, in theoretically, no one tell us like this is the parity, means this is the error checking method we have. For suppose I am sending the data successfully, it is received by the another device, but there is no mechanism to check is it send the data or receive the data correct or not. In this scenario, how we check? This is the requirement.
Okay, sir.
Nandini, you got this requirement? Yeah. Tomorrow, as you said, na, is this okay with the string related programs or any other requirement anyone have? Vinay, Nandini, Adarsh, and Divya.
Sure.
Any requirement? Yeah, Divya.
For me, it's string only, sir.
Okay. For you, for string related, na? Divya?
Yes, sir. Only string.
String related, na?
Yes.
Okay. String related means from starting onwards you want, or any particular concept you want to learn?
From basic only.
Okay, from basic only, na? Tomorrow we can start basic onwards, string level.
Okay.
Up to string level to user defined only. No need to practice on predefined functions. We have to take all string related, whatever the string handling functions we have. For every string predefined functions we have, na? For every predefined functions we implement in our class, user defined functions we can implement on that. Is it okay, everyone, or any concern? If you have any doubt, we can split. We can split that session half an hour, half an hour. First half an hour we go for the string. Next another half an hour we go for another question. Anyone have any requirement tomorrow? Nandini, Adarsh, and Vinay.
Sir, can you tell about square root function?
Square root. Okay. Define square root.
Square root function will how it will reduce the prime function. Within less speed we can achieve the part of the prime function we can print it.
Yeah.
How it will
Suppose, if you take prime, na, prime means what we have to do. For suppose if you take 97,
Sir.
if you given the input as 97, we have to check 97 is prime or not. For that, what is the basic approach? Okay, wait. Divya, can you tell me? I want to check 97 is prime or not. What is your approach?
For that, first I'll take an outer loop which runs from the number.
Okay.
And the inner loop from 2 to that number, which is, for example, I equal to 2 and I is less than that number.
Okay.
And if number modulus I equal to 0, then it should return 0, else return 1.
Okay. For example, it is 97. How many iteration you have to do?
97.
From
This
approximately.
Like 2 to 8.
2 to 8 iteration, it is fine.
What was it?
Come again, Vinay.
97 modulus 2 to 8 only, sir.
For suppose if it's 97, na, as
Ah.
what you said, you are taking 2 loops.
Yes.
In that 2 loops, you have to reach up to 97 also, na?
Okay. Yeah.
Up to means it is divisible by 1 and itself. That is the only logic you are doing, na, there. Means up to 97 also you have to check whatever the loop you have, na.
We can take I equal to number, and from with that number, we'll do modulus from 2 to number.
That one only, Divya. For suppose if you take 9, simply you take, don't take 7. What is the logic you have to write?
Number 7, sir.
Okay, number 7.
With that number, modulus from 2 to 6.
Okay, 2 to 6 means no need to do with 7.
Because it's divisible. Prime logic is divisible by itself and 1. So we are excluding that number and 1. In between the range, if it's divisible, then return 0. Else return 1.
Okay, that means you are checking non-divisible only.
Yes.
If it is divisible means you can return 0. That means not a prime number. Okay, that's why I'm asking, na, how many iterations you have to do for that. You have to take 2.
In that number.
2, 3, 4, 5 and 6. Means 5 iterations you have to do, na?
Yes.
Yeah,
Sir,
Nandini?
if the number is less than or equal to 1, and we have to return 0, and I will take one loop, that is I, which starts from 2, and I square means I into I less than or equal to number, and inside that number modulo is an I equal to 0, we have to return 0, means it is not a prime, and we have to increment I.
Okay, means you are using square root, na?
Yes,
okay,
sir.
why we take the square root? What happens?
Because number we have to check not checking from first to last, means if we take 7, no need to check 1 to 7.
Okay.
Number by 2, square root of 7 only we need. Like we can reduce iterations, so time complexity will reduces.
Yes. Vinay got the answer from our discussion.
Yes, sir.
Why? Because if you take, as Divya said, na, 7 means up to she want to check with every number. But there is a way if it is divisible by its half, means it's square root. For suppose if you take 4, now what is the square root of 4 is 2 only. Up to 2, is it fine to check is a prime number or not? That's it. To reduce the time complexity, we are using the square root concept. Means, for suppose if you take means what? For suppose if you take 25, if you want to check 25 is prime or not, means no need to check up to 24 and 25. As Divya said, up to 24 you have to check, means 22 to 24 means at most 23 times you have to iterate that loop. It will increase the time complexity. To reduce that, what we have to do, square root means 5. Up to 5 is fine. It means if it is divisible by 5 or any its square root, that means it will divisible by more than 1 and by itself and the square root also. That means they will get 3 count, means it will divide by 3 numbers. In that way, we are checking that it is not a prime number. That's why we are using the square root concept to reduce the time complexity. Okay, got the point, Vinay?
Understand, sir.
Yeah.
Yes.
Divya, I think now you got the logic to reduce the time complexity. Now you got that logic?
Yes, sir. I know this, but I didn't say.
Okay. Just remember, no, like in the interview, what happens after you successfully complete the requirement, then again they may ask, can you reduce the time complexity on this code like that?
Yes.
Okay. Okay. Any another questions? Others, do you have any other questions?
No, sir.
Okay. Yeah, Nandini. Now you are going through ARM classes, na?
Yes, sir.
Yeah. What about the project, like lab? Is it going fine or any doubts?
Fine, sir. As of now, fine, sir.
Okay. Okay.
Sir, as Divya said, I am also having confusion in strings concept, sir. Uh, my requirement also in strings only.
Strings only, na? Okay.
Yes, sir.
Then tomorrow we will engage with strings only.